For the three vectors shown in the figure, the vector sum d equal a plus b plus c. D has components dx equal to 1 and dy equal to 0. For part A, we have to find the x component bx. For part B, we have to find the y component by. For part C, we have to find the magnitude of b. And for part D, we need to find the direction of vector b over the negative x-axis. After they gave us the picture with all the lengths and information given, we are going to take each vector independently, and we're going to write it algebraically. For example, vector A. We see that vector A has a length of 4 in the positive x direction. So if we want to write it algebraically, it will be 4 in the x and 0 in the y. Now we see that vector C has 0 units in the x, it has no x component, but it has a negative 2 units in the y. So we have that vector C has 0 in the x and negative 2 in the y. So we have that vector D has 1 unit in the x and 0 units in the y. For vector B, we have to break it into components, by in the y direction and bx in the x direction. And we're going to write it like this. It's important to remember that we have a 90 degrees in between. The problem states that vector D is equal to the addition of A plus B plus C. We have now written algebraically all the vectors. So we're going to do a list of all the vectors, one on the top of the other. This because we want the x with the x and the y with the y in the columns. Then I'm going to trace a line because I'm going to notate that the addition of A plus B plus C is going to be equal to D. And then I'm going to add each column. The x columns are going to add together. For example, 4 plus bx plus 0 is equal to 1. And then I'm going to solve for bx, and I get that bx is equal to negative 3. Then I'm going to add the columns for the y's. And we see that y is going to be 0 plus by minus 2 equal to 0. I solve algebraically and I get the other component for by. After that, I have both components of b. I can find the magnitude. I take the square root of the first term square plus the second term square. That means a square root of negative 3 square plus 2 square, and is going to get a square root of 13. If I use my calculator, I can get that the magnitude of b is 3.6. Finally, if I want to know the direction of the vector b above the negative x-axis, I'm going to see the vector as a right triangle with its components. So I see that a tangent is going to be opposite over adjacent. So tangent of alpha is equal to 2 over 3. I use arctangent function, and I have that alpha is going to be arctangent of 2 over 3. When I compute that in my calculator, I get that alpha is 33.7 degrees above the negative x-axis. And this is all what they ask in this problem.